So okay, then I'll just start to explain them one by one. I think I have just shared some photos. Okay, I'll just arrange it in an order so that the way I explain and the order which I have in the PDF will be the same. Okay, because there are some random patterns, right? And inshallah after this, I'll just go through some past papers which are similar to these. Anyways, I'll just upload them in the YouTube part. Okay, let's do more questions related to Morto in the upcoming classes. So I think let's start with that question which I said. So we have been given with a convex lens. We have been given with a convex lens and there's a pencil. So if you just go around, I think 2012, we have a similar sort of question. In that, there wasn't a convex lens. I think there was a plane mirror. I can actually remember it. But anyways, so I just gave you an idea about what will happen if you have a plane mirror. I think when we are just doing the structured part, I said you that when you are having a plane mirror, the image, so the object distance and the image formed by it will be the same. That's the thing you should remember. So, and also that's a real special property so that you can use that to find for concave lens. I think we tried some questions where we just subject it to the image so that we can coincide both the image from the concave lens, image from the plane mirror to coincide. So if you didn't get that, just let me know. Okay? I'll explain the class in the end. So in here, you should remember some points. Okay, actually, one thing is when I was learning, when I was teaching structures, I said you that we are having 1 over v minus 1 over u, sorry, plus 1 over u is equal to 1 over f. 1 over v minus 1 over u is equal to 1 over f. This is our general equation. Okay, let's forget about the sign convention. Now we should understand. Let's say if I had wait a minute. I think in the last class I said that now if I had 1 over 5 minus 1 over 3 and if I had 1 over 3 minus 1 over 5 also it will be having the same magnitude. Okay, so that's why I said you that you can interchange v and u. We can interchange v and u so that you will again get the same focal length. So just remember that concept here before you start this. That's going to matter the distance. Okay, so we are going to start from that. And usually what does a convex lens does here? Will it magnify it or will it shrink it? Will it shrink the image? So these are the key points which you should remember here. Okay, so just go through that point then. So you can see that in the 2012 paper, I think the focal lengths were not marked. Okay, but luckily you can see here this part is at 2f and this part is f. So you should understand anyways you will be having a real image, not a virtual image, because it's away from the focal length. So if you just focus on how the image will form, now don't complicate it so much. Now these are something like pieces attached, right? Several pieces get together. So at 2f there is a certain piece. Now I think in our O levels we have learned that we used to say this as the focal length, I think center of curvature. So when you are placing an object at 2f, its image will also be produced at 2f, right? I think you should remember that. When you place an object at 2f, its image also will be produced at 2f. So the ending part of our pencil should be at this side 2f. It should be at this side 2f. Okay, it should be at the other side 2f. Now pay attention to this part. Now this is between 2f and f. This is between 2f and f. This is between 2f and f. So you should understand, we might have learned that in our oral part. Now, when you are having inside the focal length, you are having a virtual image. At the focal length, image is at infinity. Between f and 2f, you are having real images. Just remember the thing, okay? When you move away from f, when you are just moving away from the f, the image will start, the height of the image will start to reduce. Or else the magnification factor will start to reduce. So, I'll just get you a note in the class again. So, just again pay attention. Inside the focal length, a virtual image. It's of course magnified. In between f and 2f, you'll be having a real image. But when you move away from f towards 2f, the image size will start to reduce. Or as the magnification will start to reduce. So, you should understand the image will be anyway smaller, okay? I'll just come to that. But anyways, if you just pay attention, I'll come to that again. Now we are having 1 over v minus 1 over u is equal to 1 over f. So if I apply the sign convention, v is anyways negative. A real image is being produced every time. So minus 1 over v. A real object minus 1 over u. Focal length is negative because of the convex lens. So I have 1 over v. The image distance is equal to 1 over u minus plus 1 over f. Okay. Now you should understand, I said your point, right? When you are moving away from the focal length, the image distance is reducing. Let's see why it is. If you look at here, let's say some values, okay? Let's say the focal length is, let's write in terms of f, okay? Let's say my image distance is f. This is 2f means, let's say 1.5f. If this is 1.5f, just consider the answer around here. Wait. If it is 1.5f, if I simplify it, okay, just take time and simplify it. Okay, I'll just take that and say 1.5f and try also for 1.8f minus 1.8f plus 1 over f. Just check the values for both of these so that you can get an idea why it is happening so. From our equation only the things are starting to change. Okay. So when you move away from the 2f, okay, so I just evaluated the values, okay. So for when u is 1.5f, I'm getting an answer like 3 for v. For v I'm getting 3. For v it is 3. And I think for 1.8 I'm getting v is equal to 2.25. You can see the image is getting smaller and smaller. It is in terms of f, okay, but just for a rough idea I just gave you that. So let's come to the part again. So you should understand when you move away from f, the image distance will reduce. At the same time, the image height will also reduce. The magnification will reduce. So soon say me, the magnification at here has to be larger. When it move away, the magnification has to go down. Okay, so these are some points you should remember. So let me just draw the diagram, okay. Anyways, you know at 2f, the edge of the pencil, so not the edge, okay. The corner part of the pencil must be present at 2f. So at 2f, I have this part. You should understand the thing. Compared to this part is smaller. Because why? This part has a better magnification compared to this. So it will be something like this there. A zoom part. Something like this. So in that the answer has to be, it has to be the second one, okay. Not that much larger also, but it has to be the second one. First one is so, you can see the edge is at this corner. That's the wrong part, okay. It is your answer 2. Okay, so I'll just discuss if you want in the class as well. So pay attention to these key points. When you're in a convex lens, if you are moving away from the focal length, image distance reduces, magnification factor reduces. Okay, these two things. And I went to say something other, right? Yeah. So whatever geometry, okay, no, in here we had a pencil. You can have anything else. Just don't worry with that. Okay, you can just consider as two edges. And after that, usually a convex lens part is making it magnification. Just remember these three things. So we just get an idea about a convex lens, right? So next, let's move to a magnification part. So we are having the word physics on a sheet is 14 millimeter height. So anyways, I'll just arrange them in an order, okay, so that it will be easy for you. The word physics on the sheet is 14 millimeter height. So I'll come to that, okay. It is observed through a convex lens. So we are using a convex lens of focal length 16 centimeter, okay, and it seems like in the neighbor figure, okay, they have given you a figure, okay. The height of the image formed by the lens is 56 millimeter. So the lens between the, the distance between the lens and the sheet is. So I'll come to that. So I'm just erasing these. So I think that's why I said there was a structure, 2015, 12, that period, okay. Just go through it. But anyways, now I have the word physics. Let's say PNH. So in the, let's say it's just like in a textbook. Now they are using a certain convex lens. This is our magnifying lens, right? In basic case. So what does a magnifying lens does here is, it is gonna zoom the smaller letters. So when I place it on top, it is able to see that the physics is appearing like this. Somewhat zoomed, okay? Let me just shrink the size. So it is somewhat zoomed now because of your convex lens. So just get those details, what is actually happening here. The height of this is actually, I think it was 14 millimeter. The height of that PH part is 14 millimeter. When you are using this magnifying lens, it became 16 millimeters. Okay, sorry. It became 56 millimeters. Okay, you can see it has been zoomed, okay, by a large amount. 14 millimeter height was zoomed to 56 millimeter. Okay, so the focal length of the convex lens is 16 millimeter. So they are saying us that, so they are asking you that if the height of the image is this 56 millimeter, the distance between the lens and the sheet is. So we are having the lens here. So there is the part where physics is present. So they are asking the distance between the lens and the sheet. So this is your sheet paper. What is the object distance? Am I right? They are asking you the object distance. So before I just move to this part, you should answer me whether a real image is formed in this case or a virtual image is formed in this case. So I think you might have learned about optical devices. Is there a real or a virtual image? If you are so confused with that, you can just see, if I want to see the image, my sheet is here. So the image has to be produced forward to my eyes, right? It can't be formed behind my eyes. Then I can't see it. So the image has to be, that means if there is my eye, the image has to be here. Then only I can see that. So if it is in the object if it is in the object side, then it's a virtual image anyways, okay? Just remember, okay? So what I left, okay, so actually I'm asking you the object distance. So let's try to find it then. So with this information, how I'm gonna do this? Now you can try it in any ways, okay? I'll just say that. Now this is my, let's say I just gonna consider only this P part, okay? So we are having this P. So the height of that is 14 millimeter. Now you might confuse yourself, okay, should I draw the principal axis like this? That means if P is this, should I draw this way? You can have those doubts, okay? So I think no need to just confuse that much. Get that point. The principal axis can either go through the middle or you can either take it from here, okay? It's not a problem. Because even if you're having when I do the calculation, you see that. I'll just come to that. If it is exactly half, you'll be having 14 divided by 2 and 14 divided by 2. So let me just start in the basic way. The height of this is 14 millimeters. So the image height, the image which is produced here, that is 56 millimeter height. That is 56 millimeter height. Okay? So you should understand, you know, V over U is equal to HI over HO. HI over HO. So which means you'll figure out that V is equal to image, distance is unknown, okay? Image, this is what I am required to find, U. HI is 56. H naught, height of the object is 40. I think we can divide it, right? 4, 16, 1, yeah, 4. So we'll be finding that magnification factor is 4 and V over U is equal to 4 here. The thing is, I think I made a mistake when I was trying my exams, but I'll just recall it. Okay, the thing is, if you really want to find whether it's upright or inverted, you can use the sign convention, okay? The sign convention is, you can see it's a virtual image. This is positive, but this part, object distance, will also be positive, okay? So positive, positive, anyways, it's this way. So I think I can remember, but I made a mistake with this when I used the sign convention. I'll recall it, okay? So when they specifically say that inverted upright, be careful with the sign convention also, okay? I can remember what I did, but there was a mistake which I did from that case. We are having the sign convention in real images, virtual images. We'll be having the sign convention for them. Apart from that, for inverted and upright also we have the sign convention, okay? So anyways, we found the magnification factor as 4. Now we can just work through that. We know 1 over V minus 1 over U is equal to 1 over F. So if I write, I don't know any of them, okay, V and U, only the focal length is known. It's a convex lens, so it is negative. If I write it here, I think we can see that, yeah. So that we'll be having a virtual image, positive 1 over V minus 1 over U minus 1 over F. So my V is unknown, okay? Now see what I'm going to do. But I know an idea that it's V over U is equal to 4. So you might think, okay, if I multiply everyone by V, here it will be 1. Here I have V over U. That means we know the answer. Here it is V over F. So you might think, okay, I can find, but you're going to find V only. We are not going to find U here. So if you really want to find U, multiply by U, okay? Those confusion might come in the exam hall. But anyways, you'll do that easily. But I'm saying, okay, I'm required to find U here. It's really a time waste of finding V here. So if I just multiply by U, I'll be having U over V, not V over U, U over V minus 1, which is equal to minus U over F. Let's see whether you can see that. That's right. Now you know that v over u is 4. So u over v is 1 over 4. 1 over 4. I think 1 over 4 minus 1 is equal to minus u over, I think it was 16. 16. So when you simplify, you'll find that u is equal to multiply by 16 means 4 minus 16 is I think 12 millimeters. Just check that, okay? You'll be getting 12 millimeters. So I think I made a mistake something like here, okay? When I was trying my FWC paper, instead of saying these stuff, they just gave a question where they have said it was an inverted image, something I can't remember that. The magnification factor they have given they have given the magnification factor. They said it's an inverted image. Even if they are not saying you that, you might have that idea, okay? If it is inverted, you will be having a negative magnification factor. When I find that, I'll just give you, but be careful with that, okay? So anyways, you'll be getting an answer like this, okay? So you can also try that structure. Let's discuss it tomorrow then, inshallah. So that is that done. After that, we had okay. So after this, we are having some okay. So after this, we are having another easy part. Okay, I just want you to check the idea on what vectors and scalars. That's it. From mechanics, they are saying a certain point P, its x coordinate is 2 and y coordinate is 6. X coordinate is 2 and y coordinate is 6. So instead of writing the coordinates, I'll just draw that, okay? X coordinate is 2 here. Wait a minute. So you can see that if this is my origin, point P is situated here, x coordinate is 2, y coordinate is 6. This is point P. A force X is acting 3 Newton and 4 Newton. There is 3 Newton and 4 Newton, I think. Okay. So if they are giving if y is minus 4 Newton, it's in the downward direction, okay? So just those stuff. After this, they are saying us, it has moved from point P to point Q. Point P to point Q. Point Q is x is 14, y is 1. Something around here. X is 14, y is 1. This is point Q. So the force will be again remaining the same, okay? It is 3 and 4. Because you should understand, now these forces are not in equilibrium, right? So anyways, it will make the object to move. So after a certain time, the forces are still present, but their relevant coordinates has changed. Now this is the exact way of measuring the displacement, okay? So you can see the displacement initially was, okay, not the displacement, initial coordinates were 2 and 6. Now you should understand, it has moved in my x. You can see, in the x-axis direction, it has moved this way. From coordinate 2 to coordinate 14, which means it is having a gap of 12, right? It is having a gap of 12. It has moved from P to Q. So in the x coordinate wise from 2 to 14, and in the y coordinate wise, you can see this gap from 6 to 1. From 6 to 1 this way. So which is a gap of around 6 minus 1 is 5. Now you might confuse this thing. What Now they're asking you the work done. We know the equation for work done, that is force into distance traveled in the direction of the force. So I'm giving a force of 3 Newton. So it is moving in a direction of 12. That's what the water you might have memorized even. Work done is force into distance traveled in the direction of force. My direction of force is in the x direction. The distance travel is this, from 2 to 14. So 14 minus 2 is 12. And I am providing a force of 4 Newton. Okay. I'm providing a force of 4 Newton. So it has moved a direction of, it won't happen, okay, because you can see the resultant force will be this way. So it has to move up, okay. So just take this 4 Newton downward. But anyways, the answer will be correct. But conceptually it's wrong, okay. Because you can see the resultant force is this way. It will move this direction. If you want to move it this way, this force has to be downward. Then only my resultant will be in this direction, okay. Slight error, okay. Just change that. Fy has to be minus 4 Newton. So that's it. Wait, I'll just come. So 3 Newton, it is moving a direction. Okay, wait. Oh no, let's try that question again. Let's see whether there's an answer. You are providing a force of 3 Newton. So it is moving the x-axis direction of from 2 to 14. So 14 minus 2 is 12. Work done in the x direction is 3 Newton force. Distance travel is 12, which is 36. Okay. Work done in the y direction is, you can see the force is in the upward direction, but the direction traveled is in the downward way. So I said it's not a possible to have, right? But if you take the case like friction, the friction is against your work. You are trying to move forward, but the friction is acting in the opposite direction. So it can be a scenario like that, okay? So they haven't explained, but let's say it's a resistive force. So you can also relate with that. So you can see there's a force present in the upward direction, but I am moving in the downward direction. So the work done in the y direction is 4 into minus 3. Minus 5, I think. Minus 5. Because why? Force is in the upward direction, but I am traveling in the downward direction. It's not in the direction of motion. Okay. So I am having, I think, around minus 20. So you should understand this concept, okay? So unless they say that, don't take a decision like me, okay? So anyways, I was just thinking, okay, if these two are the forces acting, then resultant is this way, it has to move up. But there are cases like resistive forces, right? They will be against the motion. So we consider negative work on them. Okay? So just as a homework, try to find the total work done. Okay, and yeah, let's do another way in the next class, okay? And I'll just record the upcoming past paper series based on them, and there's another one essay. I'll just discuss that also, okay?